Kirku, and I'm a developer for the OpenSIPs project. How many of you here have heard of OpenSIPs? Great. So in the following presentation, we will be discussing about sort of like a latest buzzword that has been going on our mailing lists, this so-called Mid-Registrar, and all the stuff that goes with it. In fact, the idea started off not more than 3 months ago, and we thought it was a cool concept, and we just went ahead and made a prototype. So in the following minutes, we're going to go through what we are trying to solve with this idea, how we implemented it, and all the challenges that go with it when you're actually throwing it into the real world. And to conclude, we'll be doing like a really cool simulation of a system where everything will go into place, and you can get a feel for how useful this is going to be for your platform, or if you can get something out of it. So let's jump back a bit and take a look at how mobile has been changing over these past years. And here I put up a report from Ericsson from 3 months ago, and it's showing how the mobile subscribers have evolved from 2011 up until their projected numbers for 2021. And not sure how big the font over there is, but what's to take from this is the blue line, the subscribers, which is gradually growing to the 6 billion mark. And also, even more interesting are the dotted purple one, I think, which shows how many of the subscriptions have internet. So a quick question, why are the subscriptions, together with the mobile ones, exceeding the 7 billion mark? I mean, there's only 7 billion people, and their projected is 9 billion. So it's pretty easy to explain, right? Because it's not uncommon for people to have more than one device. We have a phone, a tablet, multiple phones, and this goes to show the trend in VoIP. And the good part is that a lot of these guys who get more and more internet are going to use VoIP, so we need to prepare for it. So I'm going to give you like another quick brain teaser. So if I mean, I don't expect everyone to get this right, but strictly intuitively, if we were to when building a PBX system, if we were given the choice between our users using desk phones versus mobile devices, what do you think would be cheapest for us as infrastructure builders to have? Would we rather that they all had desk phones, or would we rather they all had mobile phones? Which is the cheapest for us to build?
Desk phones.
Could you raise your hands for desk phones, please? Right. And this is a very SIP-heavy question, a SIP quirk, if I can say so. The reason behind is actually the problem and what we're trying to solve with this Mid-Registrar. And of course, the desk phones were the correct answer. And the reason for this is the SIP registration time. So I'm going to go quickly through the SIP registration concept, just in case we help anyone here with it. So when you plug in a SIP phone into a network, it has to announce its presence. It needs to announce where it can be contacted. And as soon as it does that, it can receive calls. So that's the basic idea for calls in VoIP. So when talking about a desk phone, we know it has a stable location network-wise. So we don't expect cables to get pulled off or network topology to change. It's all going to be the same thing day after day. So the manufacturers improve the quality of SIP by imposing these long lifetimes of registrations. So we can even afford to make them an hour long. So phone registers says he'll be available for 1 hour. And they periodically generate this kind of registration traffic. On the other hand, with the new mobile technologies, they are so dynamic, right? The network topology can always change. You can switch from, you can at one time be on your Wi-Fi, then you can switch over to 4G, or the hotel may time out your connection, or I don't know, you may run out of battery, or you may just turn it off because you don't want to be disturbed. All of these are network events, and they ultimately you end up with a zombie registration on the SIP server for the amount you registered for. And for manufacturers to cope with this, they impose these really short registration lifetimes. So in order to minimize the impact of these problems. So if the phone announces he'll be available for 60 seconds, you can just turn off your Wi-Fi. So there won't be a real problem if your registration sticks there for another, I don't know, say 30. So this is the major difference. And let's look a bit of how this impacts our PBX. So if this was our normal scenario with the long registration times, when we switch over to mobile, we'll notice we get a lot more traffic. We get up to, if we do the division, up to 60 times more registration traffic. And all of this is without us having changed anything. It's just about what users switch over to. And ideally, we'd want to keep using or scale as easy and solve this problem as easy and quick as possible. And so this is how the idea took place. And let's enumerate a bit on what we'd want it to solve, how we'd want it to work. So it would have to be some kind of an in-between component, right, between the user and Asterisk. And we'd want it on the input part to eat up all this, quick and heavy traffic, while on the other side, on the Asterisk, we would want it to prolong these registrations. So we have a much better utilization of the resources over there. Also, this is another, I'm going to detail it in the next slides, the imposed expirations idea. Because this component would, of course, it would be some kind of a registrar, but it does not take lifetime decisions. Here, I mean the registration lifetime, it does not decide upon it. So it just has to use whatever Asterisk recommends. I'll go through it in a bit. So how would it look like? Basically, we would register. Here we have a mobile device, we have the Mid-Registrar Asterisk, and we'd register with these 60 seconds. We'd get it extended, and all subsequent registrations are just absorbed by the registrar up until the interval passes, and again we have to refresh the binding on the Asterisk. And we have restored the behavior we had previously, but now with the new generation of devices. And all we had to do was insert this component. So let's just see how this would work if the users had multiple devices, the idea I was mentioning in the beginning. So we'd have the first one register, all right, just as before, extended, and subsequent registrations are absorbed. And the second device does a similar thing, announces its presence, and behaves just like that. How would calls work? Well, since everything is on the Asterisk, now all the registrations, it can do the parallel forking And here's how it would look like. Right? This is just a SIP. But we can take this a step further. We can reduce the amount of traffic on the Asterisk even more. Because after all, the user has signaled his presence. So we can combine his two devices and just tell Asterisk, hey, this user is available. So this is what we like to call throttling by username. So we have the device registers, right? We extend it over to Asterisk, but then his second device does the same, and we can simply skip the forward, and subsequent are again absorbed. How would calling work in this case? Because Asterisk only knows of one device. So invite, of course, goes to the mid-registrar, and it will handle the parallel forking now. And from a SIP perspective, this is totally okay, and this is how it's used in a lot of scenarios. Yeah, this is the further optimization we can do. So, but when you go in and ahead and plug all of these into a real life setup, you'll find that often enough you have to make certain additions. So the first thing we faced was that thing related to expiry time I was mentioning earlier, because the mid-registrar is neither just a proxy nor a main registrar. It's something in between. So Asterisk, if you instructed, say, hey, extend this to 1 hour, it can go back and said, okay, I did it to half an hour. And this way your processing suddenly changes a bit, because you no longer do it on the request, but rather on the reply. So here's how everything would look like. We'd have the initial registration, we prolong it, like a proposed time, but then comes the real time, because Asterisk is, after all, the main registrar. And he says, okay, half an hour. And only now we can, or he may even reply with a negative. He may give us a 4XX for some reason. So only now we can truly say that the user is registered on the platform, not before. And of course, it will take care of the proper conversion back to 60 seconds heading back to the user. This is expected of it. So another issue that we need to carefully take care of are the zombie registrations. Because as I was saying earlier, clients really go on and off all day long. And their registrations, while being properly expired and removed on the OpenSIP's front end, they will stick as zombies on the Asterisk side, because we just extended them to like full hours or big numbers like that. So all of a sudden we are faced with the problem of having to deregister these users whenever we detect the timeout on the mid-registrar side. So let's take a look at how everything would look. We have the registration, we extend it, and 60 seconds pass. And now of course we invalidate the binding here, but we need to deregister it. Another thing that we face is how do we adapt to the SIP authentication that was already in place when we add this middle component? Because again, things they won't work right out of the box. Ideally, we'd want to move everything on the OpenSIP side. We'd want to handle the registrations over there, and simply, since everything is done internally on the platform, Asterisk is just trusting our IP and forwarding everything there. But in some scenarios, we won't be able to do this. And we will have to keep doing the authentication on the PBX. And the deregistrations I mentioned earlier will come back to bite us because, again, we need to come up with a solution to generate authenticated traffic from the middle box. We can do this in two ways. Either with the trusted IP idea, and if it's possible, of course, or with some dedicated authentication credentials for the mid-register box. And here is how everything would look. This is the first scenario, the ideal one, where we move everything on the front end. And if we need to keep it on the asterisk, of course, it will. It's just a proxy type of setup for most of the calls, but I mean registrations. But the problem, like I said, were the deregisters, and those we could simply have the box accept as they are, or here I'm going to go back on the full authentication flow, or we could do that additional user. So this is how everything looks for the proxy mode, but with the SIP user and authentication user. I don't want to get too much into this, but you'll. And when generating the deregisters, we can do this trick of having different SIP users and authentication users. Now, again, this is some setups do not allow this kind of traffic. They will just say it's malicious, right? Bad intended. But again, we have so many options that one of them is going to work eventually. So either right, IP, SIP, the SIP authentication. Maybe even we could come up with a third one. Maybe external authentication. Why not? Just add a service and do an additional query to fix it. So in the next minutes, I'm going to do a demo, and so we can get a feel for everything falls into place. And let's take a look at how what we're going to have here. So all of it is going to run on my laptop, and we're going to have 5,000 users pushing their registrations over to the new Mid-Registrar module in OpenSIPs. And again, all of these will be forwarded to yet another box, an Asterisk. And we're going to look at graphs. We're going to see how everything falls in place and draw some conclusions. So here's how the timeouts will be, because we don't want to be waiting here like 1 hour to see some deregistrations. And I just picked like from 60 seconds, just extended to 150, reply with a different one. And that's basically going to be it. Here is where we'll be monitoring everything, and I think it's better if we talked a bit before we launch everything. So on the upper side, we have the mid-register layer together with the asterisk, and that shows calls per second. And on the bottom side, we have the user locations of the two boxes, which are now showing plain 0 because nobody is registered. And everything is started. And now I will be, by the way, the users, since you cannot do it with any sort of traffic generator, right? The SIP-P or, I just wrote a Python script to generate all the traffic. So, right, I just started it. And initially we'll see all the traffic being forwarded, right? It will be matched between the two instances to be identical. And the user locations, of course, are growing up to what we had, 5,000. Regarding the algorithm, it's a bit randomish, as in they don't register in bursts. They're just picking, like I don't know, 200 something periodically just to get a nicer view here. So soon enough, we'll see all of them being nicely synced up, and all the traffic on the Asterisk will fall to like maybe 0, right? Because we are imposing such long lifetimes. I mean, in this case, it's not that long. It's just 2 times more, but we'll get a feel for how it works. In real life, we'd just say 1 hour. So we'd really have 0 traffic there. So the downward spike is when they are all registered, but now they're starting to re-register on the OpenSIPs. But the Asterisk has no traffic. What you're starting to see now is some initial registration starting to expire, but the random hasn't started picking them again. So, of course, we generate some deregistered traffic to remove them. So that's the little spikes here. On the bottom side, we see everything nicely synced up at 5K. And here we can see it's still soaking up all the traffic. That part never stops. They just register like crazies. And yeah, I'll just give it like a couple more seconds before. I mean, I'm really dying to see what happens if we just unplug everything, right? Because if we stop it now, if we stop sending in the registrations, the left-hand side, of course, will just be leveled up to 0 input traffic. But soon enough, we'll be starting to see like a storm of deregistrations because all of our users, 5,000 users, turned off their Wi-Fi. I don't know, some big downtime. And we're just starting to see everything being deregistered on the Asterisk part. And soon enough, they will all deregister. Yeah. You can notice like some tiny differences between how they drop here. This is because of the way they're done. Here they're done on in-memory kind of timer, right, in OpenSIPs. Whereas here, it's just SIP traffic processing on the Asterisk, so it's much more smoother. Yeah. Okay, so right now, they are all cleared up, and of course, this is a totally abnormal scenario, like who unplugs all their users, right? But just to play around with it. So let me resume everything here. So to make a summary, we started with the why. Why there is a need for this idea, this module. And then we discussed how it would work, what kind of needs we have for it, given on our own platforms and use cases. And then we actually ran through how this works. So as a takeaway message, when building platforms, it is important to know what is the role of each software component, like what is exactly best for, because this allows us to use and best utilize our resources. And we might not notice improvements immediately for this optimization on small deployments, but when you get to those big numbers, those resources that you save really start adding up, and they might save quite a lot of not really, I mean, of course, money too, but orchestration overhead, because you suddenly have to start adding so many boxes, you have to start balancing towards them, and things like this. So the effort to maintain such platforms with big nodes and with lots of nodes, and you could save all this headache just by adding some cheap solutions such as this one, and also completely free. And yeah, this was it. If you have any more questions, please go ahead.
We have a good amount of time for questions, and this was pretty impressive what they're going on. JR?
So yeah, this is incredible. I like this. So this is the mid-SIP or mid-registration.
Mid-Registrar.
It's a module in OpenSIPs now.
Yeah.
The question is if this was a module that's in OpenSIPs right now.
It's currently on a separate branch, but now that I'm saying it, I realize I haven't pushed it to, to GitHub yet. But yes, it's going to be pushed in the following couple weeks on the development branch, and it will end up in the upcoming 2.3.
Question in the back? The question is on multi-tenant. Can it handle multi-domain and same users with different domains?
Of course. This is basically due to how OpenSIPs handles multiple domains. You can just work with them on separately, and yeah, it will work right out of the box.
Natively, OpenSIPs would be multi-domain. So, I mean, this is something different for an Asterisk thinking, but this, I mean, it's phenomenal, but it would work multi-domain. JR again?
And will it support other methods, as in options, notifies?
Question is if this will also work for options and notify and any presence, I guess.
Yeah,
I'm going to
presence,
add
exactly.
to it.
So the way I wrote it, maybe not immediately, because it's a bit tightly bound to the user location code, but I guess it's an excellent idea, and we could extrapolate it further and make it like move the code separately so it can be used by the presence, maybe make an API. So immediately, no. That would be the answer, but it's totally possible.
Another question in the back. Just two people so far.
So
The question is about having multiple registrars, so two mid-registrars, and tell me if I'm wrong here, you're talking about passing one registration to one OpenSIP server to another OpenSIP server, and then to
Asterisk.
Yep.
Of course, I guess you'd have the mid-registrar be the second box, so not the one in the DMZ, right? Or that's how I would put things into place in this one. So instead of two registrars, you basically have three. So either one can be a mid-registrar. All of them can be. It's just up to you how you want to orchestrate them together.
That being said, if you were doing it just to hide your topology, you might want to talk to them, outside of this, but OpenSIPs would be able to handle that type of topology hiding with just the one box and incorporate it with this as well. Yeah. These are good questions. Oh, new one.
Yeah.
The question is regarding the web interface that's on the screen now. What is it? It's awesome.
Yeah, I am totally bad at web, right? I'm horrible. But even so, it's called Grafana, and you can easily just plug in graphs. You can, and it works together with a real-time statistics kind of database. Again, it's a new thing. I haven't heard of it before. It's called InfluxDB. So it's quite easy to get set up. You'll find loads of tutorials, and yeah, you can start. OpenSIPs publishes statistics like every second, and by HTTP, everything is running locally, and yeah, that's pretty much how it works. Grafana, InfluxDB.
I have a follow-up on one of the questions from the back. So if I did have, let's say, geographical nodes, the way that we would do it with this would be, I guess, have multiple OpenSIPs, then use an OpenSIPs as a mid-registrar to, although, at this point, I couldn't imagine having just one Asterisk with all these other servers. But, I guess you could have multiple OpenSIPs that connect to another one as a mid-registrar, and that would do the same
exactly
type of throttling.
the same type of traffic conversion. Yeah.
And that would give you some sort of failover in addition as well. But the scenario is weird. Any questions that you can think of regarding the OpenSIPs project or more on the mid-registration? Again, this is pretty new. I mean, you said it was 3 months?
Yeah, it was 3 months we came up with it, and we actually invite you to, if you have any ideas regarding how you can improve on this, don't hesitate to post on the list.
So currently what embedded now, what are some of the configuration parameters you would use? Registration time?
Oh, I can show you.
Questions regarding the configuration parameters that you would need to set this up?
So it's quite easy. There's like only a couple. So on the left side here, we have, it's just the mode, right? So you have the mode where you tell it to work in that, per device or per username, the optimization, and the outbound expires. And you have several others regarding the way you want to do call routing afterwards. I mean, again, this is getting into SIP intrinsics. You can either do it by path headers, but if for some reason, Asterisk has some problems with those, or the media server you're front-ending, you can just rewrite the domain as you go to it, so it can send them initially to you and not to the contact. Right.
So on the SIP device,
so
the soft phone, it would actually, you would probably use the outbound proxy would be the OpenSIPs box, and
right.
the actual registrar would be the Asterisk box sitting behind it. You use the domain table to convert and send it properly, or like that, or?
Yes, like you either use that or just by path. You can add a header. I'm not sure I understood the question. Sorry.
And I guess on the module is called Mid-Registrar
right.
on OpenSIPs. What's the website again? The OpenSIPs dot. Is it com? .org.
.org.
Any more? All right, perfect. How about a round of applause? This is a pretty impressive demo there.
Thank you.